Hey guys, welcome back. So in this video we're going to discuss about multi-threading. So even before going through to the multi-threading, so let's discuss what multitasking is and how our operating system allows us to run multiple tasks at the same time. So the multitasking is, so here we have a multiple tasks, like so we have a browser process, an Excel process, and some VLC media process. So all this process are running, uh, okay, they are running simultaneously on our system. But is it possible that multiple tasks can run at the same time? So operating system sort of manages the execution of this task and make sure that each task is processed in some way. So the operating system is actually making sure that multiple tasks can be executed in the system. So this is a one way of achieving a multitasking, and there is something called as multiprocessing. So in multiprocessing, we have a multiple cores of CPUs. So if we have a multiple cores of CPUs, then we can assign a single task to a single CPU and another one to another CPU. So in this way, we can segregate the task and also achieve something called as a multiprogram. So here in 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 these two examples, so it is a case that in multitasking that multiple process can run, and in a multiple processing, so using multiple processors, so we can assign a different task to different CPU. But the core example is that so we wanted to achieve something called as a multiple programming. So multiple programming is nothing but it is a style of executing the programs which allows the operating system to execute multiple jobs simultaneously. So it's kind of having the same definition as the multitasking. Then how the multi-programming is different. So a multi-programming is only concerned with having multiple jobs in the job queue, but it is not concerned about about their execution. So in multi-programming systems, it is not assured that each and every job will get its own time. So so they will be executed in terms of a scheduling which is predefined. So it might be a case that a job one is actually taking up all the time, and the job three had to wait for a long time. So this is not a great way of executing the processes, right? So, so a unique case of a multi-programming is called as multitasking. So multitasking, so it uses an algorithm called as round robin. So using the round robin scheduling algorithm, it is going to provide some sort of a time a slice for each and every process, and the process will be executed for that amount of time, and it will be taken out from the CPU. So in this way, a multitasking handles a concurrent execution of a lot of tasks at once. So then why do we need multi-threading? So even in multitasking, so whatever the process that is running simultaneously, it is still a process. So what if there is a case that even the processes have to be shut down internally? So even they have to be they have to be executed independently of each another internally. So if you were to create an internal mechanism inside the processes through which we can execute some portion of it in a different way, so we can achieve that using multi-threading. So using multi-threading, for a single process we can define multiple threads. A thread is nothing but, so a thread is just okay, an execution sequence. So it is just a set of statements which are supposed to be executed at a single go. So we define threads at a logical level. So let's see the threads. So here this program has two tasks, and each task is actually handled by a thread, and using the thread the processor is going to execute this thread as part of the round robin a scheduling mechanism, and these threads are responsible for finishing this task eventually. So this is how the a thread-based multitasking happens, and how are threads are treated in the JVM memory. So a thread will have its own stack. So since all those methods are not conflicting with each other, but the heap memory will stay. So will be staying as a shared resource for all of them. So multiple threads might, so it might be a case that they might operate on the same object. It might create some sort of a data corruption issues. So we'll see how to handle them as well. And uh, and each a thread will have its own a cache. So it will have its own program counters, its own local variables, uh, which will be used for the context switching. And then so here we so eventually in Java, so any program will have at least a single thread, so we call this as the main thread. So any program so will have a main thread, but if you define some, okay, so if you define some more threads internally, then it will become some multi-threaded processor with the main thread as well as some other worker threads, so which work along with the main. So here each thread has its own stack, its own registers, but the data and files and the code, it will be shared among them. And then this is the life cycle of the thread. Okay, so this is how we create a thread. So with the thread t is equals to a new thread, and since we have created a thread, so it will be in the a new state. And after on that object of thread, if you were to call the method start, it is going to make that thread a runnable instance, so it can be runnable. And if we call the run method giving some kind of code, it will be in the a running state. And from running state, so due to some sort of methods like sleep and wait, it might go into a non-runnable state. A non-runnable state could be anything. It could be waiting for a resource, or it is made to sleep, or it is made to wait. Whenever what the so and whatever the task for which it went into non-runnable, if it is completed, then it will come back into the runnable state. And then after and when after the execution was done, and whatever the code which was given in the run method, if it is completed, so the thread will be terminated, and whatever the resource was, and the memory allocated for the thread, it will be destroyed. And then, okay, then the management of multiple threads. So here we have two concepts called as asynchronization and concurrency. So let's assume, so the asynchronization, it works in a way that it only allows a single thread to make change to a shared object. So let's say the increment is the object which is shared among all these threads. So if one thread is trying to call the increment method, the other threads have to wait until the first thread has completed its execution. So this asynchronization can be achieved using the asynchronized keyword. And on the other hand, we have something called as concurrency. So concurrency allows multiple threads to access the same resource. Even in this case, it is going to ensure some sort of reliability by making sure that the increment method uses some sort of atomic variables, or it uses some sort of concurrency mechanism to ensure that the data will be staying consistent. So in this thread synchronization, we have multiple ways of synchronizing. So we have the process synchronization, which is not a topic, and then we get to the thread synchronization. So it can be done either in the inter-thread communication way. So using the cooperative multitasking, so we can make sure that the two threads, so they will be calling upon the wait and notify on each other to make sure that when the resource is available to take, the other threads will be able to hear the communication. And then we have something called as the mutual exclusion. So using the mutual exclusion, we can write the asynchronization methods or block or a static synchronization. Through these ways, we can create a block which can be only accessed by a single thread at a time. And then we have the java.util.concurrent API. So this concurrent API provides a concurrent collections, concurrent queues, asynchronizers, executors, logs, and atomics. So all these things are related to the concurrency management system. So these are used when you are creating a multi-threaded environment, and you want to asynchronize some sort of task, and or if you want to execute some task for multiple times, or if you want to create logs, enable logs, and make some variables atomic or volatile, so we can use the java.concurrent API. And then we have something called as an executor service. So since if you're supposed to create multiple threads, so it is actually a difficult task to sort of create and manage all of those threads by ourselves. So instead of manually creating the threads, we can use the executor service. So we just have to submit all the threading tasks, and they will be present in a, a blocking queue inside the executor service. And whenever a thread is free, some new task will be assigned to the thread pool. Okay, I will be assigned to the a thread from a, a thread pool. So there are actually a different ways of using the executor service. We can create a single threaded pool, or we can create a fixed thread pool, or we can use a cached thread pool. So in this way, we can create an executor service which is going to execute some sort of asynchronous tasks for us, and it will manage all those threads internally by itself.